Number 3 says the solubility of copper 1 chloride is 3.91 milligrams per 100 milliliters of solution. Calculate the KSP. So let me look at the problem here. Maybe it'll give us some more information about this problem that this solution doesn't give us here. No, it does not. So that's okay. So we want the KSP of copper 1 chloride. Okay. So we have Cu, Cl, and this is going to dissolve into C1 plus Cl minus, right? 1 minus. And we have 3.91 milligrams per 100 milliliters of solution here. So what we're given here is we're given mass and we're given volume. So what we want to do first is we want to calculate the amount of moles here, because we need to calculate the concentration of copper chloride. So let's do that. So if we have our mass here, which is 3.91 milligrams, and what we can do is we can actually change this to grams, right? So we're going to multiply by 1 over 1,000. And this would give us our unit in grams here. Remember, we're just dividing by 1,000. So 3.91 divided by 1,000 would give us 3.91 times 10 to the negative 3. This would now be in grams. And what we need now is we need the molar mass of copper chloride, and we can easily calculate that by looking at our periodic table. So molar mass here, we can look at the molar mass of copper, which is going to be 63.546 grams per mole, plus chlorine, which is 35.45. And this is going to equal, let me just take out my calculator. So we have 63.546 plus 35.45 gives us a value of 98.996. And now what we can do is we can solve for the moles, right? Because we know that the moles is simply just mass over molar mass. And we're given our mass, which is 3.91 times 10 to the negative 3 grams, divided by 98.996 grams per mole. And this will give us our moles of copper chloride. So this here is 3.91 times 10 to the negative 3 divided by 98.996. And this will give us a value of 0.3870. So let me just say 0.3871 moles. And then what we can do now is we can actually solve for our concentration, right? So we have moles here, and then what we can do is, because we have volume, which is going to be 100 milliliters, which equals, I can change this into liters by simply, again, dividing by 1,000. So 1 over 1,000. So this one would be 0.1 liters. So I can actually solve for my concentration here, which is simply just moles divided by our volume, right? So here's 0.3871 divided by 0.1 liters, which is going to give us 0.038, I believe. So 0.3871 divided by 0.1. This should give us, this gives us 3.871. Yeah, 3.871, not 0.03, sorry. This is 3.871, and this is here is capital M in molarity. And once we can do that, what we can do here with the concentration here is we can finally set up our ice table to solve for our KSP for copper chloride. So we can do that. So because this here is the concentration of copper chloride, we know that the mole to mole ratio here, we can look here, copper chloride and Cu1 plus and Cl1 minus also have the coefficients of 1 as well. So therefore, these guys also have 3.871 times, it also has, 0.3871 moles of copper and chlorine that are being produced in solution. So what we can do now is we can actually figure out our KSP value by simply looking at our ice table here. So because we're not given our KSP for this for our equilibrium reaction, that's going to be something that we're going to be solving for. So we can do that actually. So we can set up our KSP equation as KSP is going to equal basically the concentration of our products divided by the concentration of our reactants here. So concentration of products that we're making is Cu plus and Cl minus, and we're dividing by CuCl here. And this is going to equal, well, I know that because the moles are going to be the same for copper, chloride, and copper, and I know it's going to be the same, and they have the coefficient of 1 because, again, I don't have, there's no coefficients in front of the Cu and the Cl minus, so these exponents are all going to be 1. So what I can do now is I can simply just divide out the concentrations and to figure out my KSP here. And this would give us our solution for this problem. So as you can see, this solution here is incomplete here. They wrote out a balanced chemical equation, but I don't think they calculated anything else for this problem here. But that's about it for this problem. Let me just see if I can solve for this this guy here. So 0.3. I'm gonna have to actually use my ice table to solve for this problem as well, but this here would be the given KSP value for this guy. I'm just missing one step here. So if I had CuCl, Cu plus Cl minus plus, and I know that I was given my initial concentration would be 3.87871 for my copper chloride. And this here would be 0 and 0. So I would have 3.871 plus x, or sorry, minus x. Plus x, which would be 3.871 minus x, and x here. And then now what we can do is we can solve for our KSP value. So this is simply just x squared divided by 3.871 minus x. And this here would give us the value for KSP if we knew the concentrations of Cu and Cl minus here. So again, I don't know about the solution because again it doesn't give us a solution here for this problem. So I'm going to say this here is again an incomplete solution. But if I was given my KSP table here, I can actually solve for this. I believe it's it gives us like 1.2 times 10 to the negative 6. So that would be the answer for this problem. But again, we don't have a complete solution here because this is not going to give us a complete solution. But this is kind of the steps in order to calculate this. So we're given mass here. What we can do here is we can calculate moles and whatnot, and then calculate our concentration as well. So that would give us, and we can set up our ice table to solve for our KSP here. So that's kind of the logic behind this problem here. So again, this solution here is incorrect because again I don't have a complete solution here. What we can do here is if we finish this problem, what we can do here is, let's see. I have 3.91 of 98 grams here. Did I divide this correctly? Let me just see if I found the moles here correctly, just to make sure. Because I have a feeling that something is off, because that's an awfully big concentration divided by, I think I multiplied instead. 0, or sorry, this is 98.996. Ah, yes, that makes sense here. So I think I multiplied here. So this here is my bad. So I think I plugged in a multiplication operation in my calculator, and not a division. So this guy here is actually 3.9497 times 10 to the negative 5 moles, which means this guy here would be not that. It would give me 10 to the 4 for my concentration here. Let's look at that. So it would be, again, 3.9497 times 10 to the negative 5. And this one would give us, let's see, let me divide this by 0.1. So I get 3.9497 times 10 to the negative 4. This is in molarity now. And what we can do, we can actually solve for this problem. So let's solve for this problem here. And we know, so what we can do here is we have an ionic substance here. So our products here is going to be, this concentration is going to be basically negated. And we can say that this we're basically here dividing by 1. And we basically just care about the KSP expression based off the products here. So in this case here, we actually don't need to do an ice table. Or well, we do, but we don't really care about the initial products here. We just care about we don't care about the reactants. We care about the products here, which is simply just x squared. So I guess we do have to do an ice table. So it'd be Cu1 plus, and this is Cu minus. This here is ICE. So we start with 0, and we're adding some type of x here to both of these guys. So we're gonna have x for chlorine and for copper chloride as well. And if we substitute our expression here, this here is going to be x squared, right, divided by 1. And we know that x here equals our concentration. So this here was our 3.9497 times 10 to the negative 4. So what we're going to have is we're going to have 3.9497 times 10 to the negative 4 squared. And then this here will give us our KSP value for this solution. So this is going to be, let me plug this into my calculator. This is 3.9497 times 10 to the negative 4 squared. We give us value of this is 1.56 times 10 to the negative 7. And this here is going to be our KSP for this solution. So this solution is incorrect. KSP calculated. So I'm just going to write down the steps but not do it. So it says we need to solve for the concentration of the copper 1 chloride solution by figuring out the moles of copper chloride. Using stoichiometry. Okay, and then able to figure out the concentration of copper and chlorine in solution. And related to the concentration of copper chloride. KSP is going to equal concentration of Cu plus times the concentration of Cl minus And then that's how we're going to solve for our copper chloride. So the solution here is, or sorry, our KSP of copper chloride. So the solution here is incorrect because again, I have a incomplete solution.